Hello guys, I along with my team made an interesting chat application known as Rich Chat. It is basically like what's only. We designed it for Windows and Android. In this video, I will discuss the features of this application and what are the data structures we used in it. Talking about the features of this applications are text messaging and sending, searching, faster searching approach using dynamic programming, chat history, recent chat list, and notifications. Now, I will briefly explain you each feature. The first one is text messaging and sending. In this, user will be able to enter text messages and will be able to send it to their contact. The data structure used in this will be queued using array because the message that user writes first, we want to be it to be delivered first. The time complexity for each message that the user sends will be big of 1. But if there are multiple messages queued together, then the time complexity will be big of n. We didn't use linked list here because it is not of fixed size and it will take a lot of data. And so it will make our message delivery slower. We also didn't use tag because we didn't want our last message to be delivered first. Now let us discuss about queue using array. So basically, here are two variables front and rear. They point to the insertion and deletion of the queue. Initially, the value of front will be -1 when the queue will be empty. Now assume that H is message 1, E message 2, and like that, this is message 3, 4, and 5. If we want to insert a message 6, it will be added at index 5, and the value of rear will be now changed to 5. Rear will be shifted here. Similarly, if we want to delete one message or the user is sending one message, the first will message number 1 that is H will be sent and so it will be deleted from here and then the front will be shifted to here and the value of front will be 1. Likewise, then E will be sent, then L. And if we want to add another message, it will be add at index 6. That's how queue with array work. Now let us talk about our next feature, that is searching. So user will be able to search for a particular person and he will be able to view his profile. In this, we have used hashing in array for quick searching, and the time complexity is bigger of 1. So there are three steps. First, creating hash functions, then generating value in hash function, and then storing it in the form of hash table. Assume that we have messages 1, 2, 3, 4, likewise. So the message 1 will be stored here, message 2 will be stored here, and message 3 will be stored here. It will be able to help us for it will be able to help us for searching. The next feature is fastest searching approach using dynamic programming. So here we will make the search faster using dynamic programming by finding common subsequences. The data structure used is longest common subsequences and the time complexity is big of m into n. M here represent number of vertices and n here represents number of edges. So assume there are these two strings. Now if a user search for CDAC, it will CDAC, it will give us these two strings because CDAC is common in both C, D, AC. This is the common substring for these two strings. So That's how we can faster search any contact or message. The next feature is chat history. It will display the chat history of a specific person. We use doubly linked list here because there is no size limitation like in array. If one user actually accesses the data from Firebase, we will storing it as cache so that it is easily available again until he clears the cache. The time complexity is big of n time for accessing all the chats. So this is the implementation of doubly linked list. Here, here the contact will be here the message one will be stored here two, here three, and here four. User can it will recent chat history. It will show the all the messages. They are interconnected with each other. This points to the next of the second message node and this the previous of the first message. Here, here it is null because we haven't write any message here like this. The next feature is recent chat list. In this, the we will show that the chat person name and profile picture. If we click on the contact loads the chat history with that person. The data structure used in it is doubly linked list. The time complexity is big of n for displaying all the persons in the chat list and big of 1 for moving the person who sent the message at the beginning of the doubly linked list. We didn't use array here because we don't want fixed size because we don't know how much chat history or contacts are there in our applications. We will similarly, like previous recent chat history, use doubly linked list here. It will store the contact information of person 1, 2, 3, and 4. This will be stored. This will be the storing next pointer for the message 2 and this will be storing the previous pointer for message 1. Similarly, this will be stored next for message 3 and this will store previous for message 2. It is null because similarly it is null because there is not any fifth message we are here. There are only 4 contacts here. The next feature is notification. The user will receive notification for every new messages. We will use stack in linked list because we want the newest message delivery first. Time complexity will be big O of 1 for individual push of notification and big O of n for completion. We didn't use queue here because we didn't want our first message to be delivered first. So here is the implementation of stack using linked list. First top will be initial. If there are no messages, top will be null. But if we will now adding the values, first if we add 12, then top will be here. But when we add 8, then top will be here. Similarly, these are the messages we added. So top will be at 40. And if we want to remove a message, 40 will be gone first and top will be shifted to 18. Likewise, then 18 will be delivered and top will be shifted to 33. Now, let us see the code implementation of these features. We wrote our code in C language. The first feature is text messaging. First, we have defined the structure node, and 100 is the maximum length that a string can have. We have defined a next pointer in the structure node. Then we have created a new structure for queue, and there are 2 pointers in it, front and rear. Front is for deletion and rear is for insertion. Now we will create an empty queue. So this is the function for the empty queue. This will check if the queue is empty or not. Now for adding an element in the queue, we will use enqueue. And this is the function for enqueue. It will add the element to the queue. And for deletion of an element from the queue, that is pop, we will use the function dequeue. This will delete an element from the queue. And if we want to delete all of our elements, we will use this function. This is remove all function. And in our main function, this will show a user, this will help the user to choose the operation include, dequeue, remove, or exit. This is the output for our code. We can add an element to the queue, we can pop an element, that is delete an element, we can remove all the element and then we can exit the program. I have added two elements first and then deleted the element. The element that is added in last will be deleted. Let us see the code implementation of our next feature. This is for searching. We have used hash table for this. First, we will take the maximum hash table size as 100. Then we will take multiple data types in one structure. That is phone number. The maximum length is 15. Then name. The maximum length is 50 and then age. Now, if the phone number to be searched starts from 9, it will find all the numbers starting with 9. If there is any one number starting with 9, it will return that. Otherwise, if there is not any number starting it by 9, it will look the next digit after 9. So in the beginning, we will ask the user to enter the number of users. Then we will enter the information of the number of users like his phone number, name, and age. Then we will use hashing and we will search the phone number of the person if it is available in the data type or not. And if the user will be found, then it will display the details of that user. When this is the code for the searching. I have I have inserted two users in it and their details. And I want to find the user with the number this. If I wrote the number here, it will display the information about this user. Its phone number again, name and age. The next feature is faster searching approach with longest common subsequence. This will tell if string is subsequence of text or not. If it is, then it will, like if our string is phone number, it will first check if the string is subsequence of text or not. Then if it is, then it will find the phone number in that list, in that text. And if the phone number is found, and if the phone number is found with that substring, it will display all the phone numbers in which the subsequence is coming. For example, we have wrote 4 phone numbers here and we have given the substring as 682. Here, two numbers have substring 682. So it will display these phone numbers. The next code is for chat history. We have used doubly linked list here. The maximum length of character we passed is 100 and we have created two pointers, previous and next. Initially, the head is null. Now we will create a function to add data to the end of the list. Initially head is null, that means new node is also null. And when we enter some data in the linked list, then new node will have the data and the new node next will be null. Similarly, then Then we will add the data. When we add the data, it will be added to the new node only. But the first very new node, its previous pointer will be null only. And if you want to delete an element from the position, this is the code for it. This will display all the information that we have. And in our main function, it will ask the user what she has to do, whether he has to add the element to the end or delete from any position or display the element or exit. This is the output for the program. Now let us see our next feature, that is recent checklist. We have similarly used the doubly linked list here also. We have created a structure, then added the data phone number with maximum 15 length, name with 50 maximum length, two pointers, previous and next. First, previous, the new node will be null. The next and previous order of new node will be null and head will point at a new node. Then we will insert data at the end. Then we will find the nodes to be swapped, check if the positions are valid, and if when we will find the nodes will be swapped, then after we will swap the nodes, this will print the list, and this is the main function for display and for information. Like we will write the information of three nodes, and then we will swap the elements, then it will be easily be swapped. And the next function is notification. We use stack using linked list here. First, we have created structure node. The maximum length of the data is 100. We have created pointer next. Then first the top will be null. Then we will add the data to the stack. Then new node next will be top, and top will be new node. First top was node, and now we added an element, and the new element, that is the new node, will be now the top. If we want to delete an element, first if we check if top is null or not. If top is null, that means stack is empty, so we cannot delete an element. But if it is not, then we'll create a pointer temp. It will point with top only, and we will delete that element. Then top will come to the previous element, and top will be top next. This function is used to display all the elements available in the stack. This will remove all the elements from the stack. This is the main function in which you can delete, display, remove all, and exit. This is the output of the code. I have added the elements. I have deleted the elements. I have removed all and display. Thank you.